And it is a mix and match day. You have seen all the pieces before, but we are going to bring it together in a new and beautiful manner. This is some of my favorite words are going into the title of this lecture, which means...
Am I going to hate
death?
Oh, yes. Yes. Polar form
Had a bubble letter?
of conic sections.
You just hate us right now, don't you?
Yeah. Polar forms, I should say plural, of conic sections.
What does that mean?
It means that we're gonna learn how to graph your favorite thing. Learn how to graph hyperbolas, ellipses, and parabolas in terms of r and theta instead of x's and y's.
Won't that be easier?
Why?
No.
It's not going to be
Parametric
easier.
it is.
What?
Parametric it's a breeze, like I just showed you. I mean, polar parametric is easy.
Hold on,
Like we just did.
that all what you just did was polar parametric?
No, that was just regular old parametric. Polar parametric is, not polar parametric, I'm sorry, parametric conics are easy. Remember I showed you guys how with parametric equations an ellipse is like much easier than what's it called?
Yeah, whatever.
Than the rectangular form. That was the word I couldn't remember.
Can we do that instead of this?
No.
Why?
Why?
Well-
That's what she said. Why?
Because you gotta know it all.
That's not fair.
But that is part of knowing it all.
Keep trying. You're doing great. Okay, now, first thing you need to do is,
Did you put water in here?
Did you put butter in here?
okay,
It's like.
alright, stop. Now, there is a, okay, polar form, everything happens near the origin. Okay? Here's a new idea. Now, polar forms of conics are all done in terms of one focus and one directrix. If I said one focus and one directrix, you should know what you should think of one of the three conics. Which one?
Parabolas.
Parabolas. They're the ones with one focus and a directrix.
Really?
Turns out, if you're in polar form, all three of them can be described in terms of one focus and a directrix, even an ellipse and a hyperbola.
That's annoying.
I think it's beautiful.
Of course you do.
Wait, so they
Yep.
all passed the line test thingy?
No, they're not. Well, they're polar. They're sort of. They're also are sort of polar functions, but it's a little weirder than that. Now, I want to make sure I get this one right. That I say this right. Okay. In this case, before I put this graph in, I'm gonna write
I feel
something
like
more.
I'd rather go through childbirth than deal with this right now.
Possibly true. Okay. One focus is always at the origin, which your book calls the pole, because it's polar coordinates and that's the middle.
Oh, that's cute.
Yeah, except it's a dot, not a pole, so that kind of bothers me.
It's a pole looking down.
Of course it does.
Yes.
Santa
Now,
Claus.
I'm going to start with a parabola here and put in some definitions.
Oh, yay.
Okay, here's the origin. This origin, I'm going to label F because it's one of my focal points. Now, I love this stuff, but I do occasionally mess it up, so I'm going to put it over here. The directrix, I'm going to keep looking every few minutes to make sure I get this right. The directrix is going to be out here,
Why? What happens if you get it wrong?
When he teaches it wrong.
and I have to spend more time fixing it, but I don't move the test back, so we get even more rushed.
Yay.
Yay!
Wait, when's the
Fun
test?
time.
Next week.
Oh, yay!
It's going to be a crazy mix of things.
Wait, a mix of what thing?
You'll find out when the test arrives. Now,
These things.
okay, the directrix, a point on the directrix I'm going to call
Q.
a D. Okay?
No, that made me think of me.
And a point on the
Wow.
That's egotistical.
and a point on the parabola, guys, I'm going to call P. And as you know, the rule of a parabola is that the distance from the point to the directrix and the distance from the point to the focus are the same thing, so their ratio is 1. And your book does it the other way, so I'm going to do it the other way, because that's important.
So is that the live PDF?
No. It's not. So, this quality now, I'm going to give you a new word. This ratio of
That's not a new word.
the distance, I'm going to give you a new word. The distance from a point to the focus and a point to the directrix is called the eccentricity.
I've heard that before.
Sounds awesome.
Isn't that the rate of which of curves?
Basically, yeah. We're recording, so go away. We're a little busy right now.
We don't care. I'm joking.
Yeah. So the eccentricity is 1.
Is that P times F or P like?
That's the line segment.
Oh,
We're using geometry terms. Yeah, PF, that's the line segment. Okay? Now, for a parabola, your eccentricity is always going to equal 1. Now, what happens is,
What is an eccentricity?
it's the ratio. Okay, I've got this point here, right?
Yeah.
It's so far from the, it's a certain distance from the focus. It's another distance from the directrix.
I should
Right,
my
and
jaw.
it's
Okay.
the same.
The ratio of the distance from a point to the focus, that ratio to the distance from a point to the directrix, is the eccentricity. And in a parabola, it will always equal 1, because the whole definition of parabolas are the same.
Yeah.
If
Oh, that felt weird.
If the ratio of the distance from a point on the curve to the focus to the ratio of the distance from a point on the curve to the directrix is less than 1. In other words, if the point on the curve is closer to the focus than it is to the directrix, which of the two remaining conics do you think you have?
Hyperbola.
It's an ellipse.
It's an ellipse.
Whatever.
So,
Wow. that
here's a
was
focus. So what I'm going to do is, for this to be true, I'm going to move the directrix a little, the directrix over here. Here's what this origin is now one of the foci of this ellipse. The other foci is out here somewhere, we don't care.
Wait, what?
Here's my point.
Okay, but this doesn't pass that test thingy.
Does this distance look like it's less than this distance?
No, the other one that I was talking about.
Oh no, these aren't, well, polar functions don't ever have to pass a vertical line test.
Who cares?
Plus the distance actually doesn't look the same at all.
Okay, so well, they're not the same in this case. This is supposed to be smaller.
Oh.
In this case, the distance from the point to the focus is less than the distance from the point to the directrix. So this ratio being less than 1 is a definition of an ellipse.
So there was a reason why you put. Never mind.
Yeah.
Yes, you put.
So this is like in polar form, these are how these things are defined. Just like they had definitions in the...
No, I mean, I was saying that it's good that you switch the F and the
Careful,
E.
Colin.
Yes, otherwise these wouldn't have lined up. Okay. Now, what do you think happens when the ratio of the distance from the point to the focus and the ratio of the distance... Thank you, James.
Time.
What do you think happens when it's greater than 1? What's the one when the eccentricity is greater than
What
1?
she said.
Yep, the only thing that's left. Okay, so,
Yeah.
Connor, hurry up, sit down, be quiet. Okay.
That's the word.
Wait, where are you going?
Get it.
Now, in this case, here's a... Remember how these things worked. If this is a focus, the focus is always inside one wing of the hyperbola. So the wing of the hyperbola will look something like this, and I want to check something about the directrix before I...
That's an ugly one.
It is. But it doesn't. It shouldn't look like the parabola. It should have a different curvature. That's what the eccentricity
Wait, why are we
means.
only drawing one part of the hyperbola, and why is it there and not the other way facing?
Because I haven't gotten to that yet.
I'll
The other-
English. Why is it not the other way facing?
Yes. There we go. There's the other one. And this drawing, I want to make sure I get...
No, it doesn't.
Well, it's a little bit... The idea is...
Well, that makes sense. If one is bigger than the other, then obviously one's going to be.
Right, here's my point. It's this far from the focus. It's this close to the directrix. I think this with a different point.
Wow, my gosh.
I know where it's going.
Here's another point over here, which is way far away from the focus and way close to the directrix. Either way, the distance to the focus is always more than the distance to the directrix in a polar hyperbola.
Wait,
But
so are
if your
those two
focus
parts?
is 0,
The focus is at the origin, always,
and
for
it's
these.
always.
Yeah.
So then it's simple. You just have to make sure that you're following the rules right when you're